It's Brian here with Kendalt Academy.
What we're going to try to do today is get through enough algebra to do some calculus in about under an hour.
Alright, here we go. The first thing we want to do is call the variables. That's variables, variables. So what's a variable? Well, a variable is just a letter that represents numbers. So for example, x plus 3. Let's say my friend has three baseball cards, and I have X cards, or my friend has like 3 cartons of milk, and I have X cartons of milk. Well, together we have X plus 3. We don't know what the X is, but it represents something that we may not or may know. We may not know. So, for example, let's say I have 1 carton of milk. If I have 1 carton of milk, then X plus 3 equals 4, because total there are 4 cartons of milk. If I have 10 cartons of milk, then total there are 13 cartons of milk. Okay? So variables are basically something that stands for something that you don't know. Now what if there's an equal sign and that equals 5? Well, now X could be anything, but because of this equal sign, X can only be certain things. Sometimes it can be more than one thing, but in this case it's just one thing. If X plus 3 equals 5, then that means that X equals 2. Now the cool thing is you can have more than one variable in an equation. So you can have X plus 3 equals Y. Now, if X equals 1, what's Y? Y would equal 4. Right? Because 1 plus 3 equals 4. Or if Y equals 4, then X has to be 1. The next part is this. Let's say X equals 5. Then what's Y? If X equals 5, Y equals 8. Alright? So that's basically what you can do with variables with equations with 2 variables. So you have X equals 5, Y equals 8. So if X equals negative 3, then what does Y equal? 0, right? Because negative 3 plus 3 equals 0. Now if Y equals 1, what does X equal? Well, something plus 3 equals 1, the something is a negative 2. Negative 2 plus 3 equals 1. So if Y equals 1, X equals negative 2. Notice that because X is 5 and Y is 8, that doesn't mean Y can be 5 and X can be 8. If you plug in, so let's write that down. So this one does not work because if you plug in 8 for X, you get 11 for Y, and that's not what Y is. So this one is a no-no. So just because X is 5 and Y equals 8 doesn't mean X equals 8 and Y equals 5 also works. So these two are like dependent of each other. We call them like kind of like an ordered pair. And the easier way to write them is like this. Let's see. 1, 4. So this basically says that the X is 4 and the Y is, the X is 1 and the Y is 4. And what happens is, let's see. And what happens is, X is always the first coordinate and Y is always the second coordinate. That's just the way math is. You can use A's and B's here, but then you can't write it in coordinate notation as easily. You usually want to use X's and Y's if you want to use coordinate notation. So this would be the first coordinate and the second coordinate. That's what they're called, and this is called an ordered pair. Ordered pair, like it has order. Like there's an order to it. So this is an ordered pair. Now, if I put 0 here, what goes on the second coordinate? Obviously it's a 3, right? Because I plug in 0 for X and then you get 3 for Y. If I put 2 as the second coordinate, then what's the other coordinate? Well, this means Y equals 2. So X plus 3 equals 2, and that means X equals negative 1. Okay. Now I'm going to erase some of this and I'll leave some of it. So let's see here. The next step is what we call graphing on a coordinate plane. So this is called graphing. Okay, so what's graphing? Basically what we want to do is we want to make a kind of like a visual interpretation of all these points. Now, how many points of these are there? You can probably guess that for anything you put in for x, you'll get something for y. So there's infinitely many points. In other words, you can basically what that means is you can list all the points and you'll never be able to list all of them. Or you can try to list all the points, but you'll never be able to list all of them. So basically, we're graphing now. And what is graphing? Well, it works like this. Okay, so we're doing graphing. So how do you graph? It's really simple. Let's say you want to graph x equals 1, y equals 2. This is, by the way, the coordinate plane. This is the x-axis, this is the y-axis. You graph 1, 2 by starting at the origin, which is where the x and y-axis cross. That's here. This is also called an intersection point between the x and y-axis. Anytime two things meet at one point, that's called an intersection point. Or multiple points, but yeah. So you start at the origin. This means you move to the right one. This means you move up 2. So this is right 1, up 2. That's it. So for example, this one would be right 1, up 4. So it would be right 1, up 4. Way up here. I want to put a circle around it. So I'm going to put a dot in the circle, dot in the circle, dot in the circle. We'll graph these later. Now what about negative 1, negative 1? Okay. Well, negative 1 is a left 1, and then down 1. Okay? So x equals negative 1 is left 1, and then y equals negative 1 is down 1. So you have to do both of them first, both the x and the y movement, and then plot the point, and let's put a square around this one. So this is a square. Okay? Now the cool thing is, if you plot all the points for this equation, you get what we call a line. And what that means is all the points are on the same straight figure. Okay, the same straight thing. And that thing is called a line. I think you probably know what a line is, but just in case, I'm just being very clear about what I'm talking about. So let's see. 0, 3. So 0 is x, which means you move left and right 0. So you start at the origin, move left and right 0, which is 0. And you move up 3. So that's up 3. 1, 2, 3. So this point's here. This is negative 1, 2. So you move left and right negative 1, which means you move left negative 1. Or sorry, you move left 1, and you move up 2. So this is negative 1, 2, up here. So you circle them, and it turns out these lines, these guys, are all on the same line. Like, if you connect these two dots, then it goes through this dot, basically. You can't probably tell as much from this drawing, but if you do this on paper, with graph paper, it's very clear. You plot this point, and this point, and this point is right in the middle. Or you plot this point and this point, and you connect them, and it goes through and the line goes through this point. The straight, line goes through that point. Alright, so what's next? You might notice that this line also goes through negative 3, 0. Remember, this point is negative 3, 0, because it's negative 3, 3 to the left, and then 0 up and down. Well, it turns out that any number on this line satisfies this equation, because this equation is what we call linear. It forms a line. If you plot 2 points and connect them, it forms a line, and any other point that lands on the line also is a solution to this equation. So let's just check this. This one landed on the line, so we got this from the graph. So FTG from the graph, just abbreviating. So if you plug in x equals negative 3, y equals 0. And if you plug in y equals 0, x equals negative 3. So there you go.